how to calculate net present value in Excel using both worksheet functions and Visual Basic applications. I'm not going to go through the theory of net present value, but in short, here is the equation. Looks pretty nice. I made it in LaTeX. There is a function in Excel that's called net present value, or NPV for short, but it's not actually calculating net present value. It's not implementing the net present value equation that you see here on the screen. So what is it actually doing? Well, it's doing this, and do you see the difference here? If you don't see the difference, well, it's the summation sign is starting at 1 rather than 0, which basically means that if you look at this alternative representation here, we are missing the cash flow 0, or we are missing the investment cost. The investment cost is not added in here. So it's called net present value because it's the present value net of the investment cost. So in other words, we are actually calculating the present value. The NPV function is not calculating NPV. How interesting. Let's start by making the call for our own NPV function. Use the Alt F11 shortcut to open up the VBA editor, and then hit Alt IM to open up a new module. And here we are back in the worksheet, and let's take a look at a very simple example. So we have an investment cost here of 10,000, and we have 5 years or 5 time periods with a positive cash flow of 3,000 annually. So let's try to implement this, and we can start by doing this manually. So what we're going to do here, we're going to say is equal to the cash flow divided by 1 plus the interest rate, which is up here. In this example, I just set it to 10%. And it's important to lock this by using the F4 button, or F and F4 if you are on a laptop. And we need to take it to the power of the time period. And this is going to just be equal to minus 10,000 because this is in time period 0. So there's no discounting happening here whatsoever. So why do this way? It's not necessary, but I think it's simpler to do it because then you can just autocomplete this. So we can just autocomplete this. There we go. And if we now calculate the sum, then we will get the net present value. So let me just demonstrate what happened here. This is just the sum, and this is just the undiscounted cash flow divided by 1 plus the discount rate locked to the power of the time period. So this is how we can calculate the net present value kind of manually within the worksheet. Now let's try to use the net present value function that comes with Excel. So that's NPV, and then the interest rate, and then the cash flows. And this number is going to be something different. It's not going to work. And that is because what Excel is doing is not really implementing the actual net present value equation as we talked about earlier. So there are 2 things we can do here. We can either try to just kind of modify this one, just fix it, or we can just make our very own function using VBA, which I already showed you how to. So let's try to fix it first. So NPV, one method would be to not select the initial cash flow, the investment cost, but rather select all the future cash flows, and then subtract the investment cost. A mistake that happens all the time is that students are subtracting the initial cash flow, but it's a different there. A cash flow can be either positive or negative, and you always add cash flows. However, an investment cost is always a positive number that you just happen to subtract. So what I see time and time again in the assignments I give to my students is that they are subtracting the initial cash flow, so minus 10,000, which just becomes positive. So you're supposed to subtract the investment cost or add the initial cash flow. So I just like to subtract the absolute value of whatever this is. That's a way to kind of save it, make it more bulletproof, I suppose. So now we get the correct number, as you can see. There's an alternative way you can do here, and that is just to multiply with 1 plus the discount rate. So again, let's write net present value. We can select all of the cash flows. However, first we need to select the discount rate. So just like previously, and then just multiply with 1 plus the discount rate. And once again, you see we get the correct number. So let me just simplify this again. This is just equal to this one over there, multiply with 1 plus r. So we can use it manually. Here's the incorrect answer we get from using net present value equation. And here are two approaches to kind of remedy this faulty equation. However, we can also use our very own. So this was sum, this was net present value, and this was net present value fixed. That was net present value, like an alternative way of fixing it. We can also use our very own net present value Visual Basic for Application function. Remember, we called it myNPV, and I realized now that I changed the order of the inputs. In the NPV worksheet function is first the interest rate and then the cash flows, and I think I did it the other way around. So we select the cash flows, and then we select the interest rate. And there you go. So now you can see it becomes as it should be. So we can do some quick color coding here. These guys are correct, and this one is incorrect. So yeah, that's a few different ways to calculate the net present value in Excel. And there are many more things you could talk about there. For instance, what happens if you have only the same cash flow every year? Well, you don't necessarily have to do it this way. You can just simplify this is the annuity equation. But we can cover that at some other time. Yeah. Net present value equation, net present value function does not calculate net present value. I just can't get past that. You know, it's mind blowing.